In the vast expanse of our universe, astronomers are continually uncovering the mysteries of distant worlds. The cosmos, in all its grandeur, is teeming with celestial bodies that capture our curiosity and inspire our imagination. Among these wonders are exoplanets, remote worlds orbiting stars beyond our own solar system. Some of these exoplanets are remarkably similar to Earth, while others are utterly alien, challenging our understanding of what a planet can be. Today we delve into the latest groundbreaking discovery that has left scientists astounded, a new class of exoplanets that defy our traditional notions of planetary composition. These are worlds where the surface is evenly split between solid land and liquid water. Imagine a planet where one can stand on the edge of a continent and gaze across an ocean that encompasses an entire hemisphere. Welcome to our exploration of half-rock, half-water worlds. To understand these incredible half-rock, half-water worlds, we must first grasp the dynamics of planetary formation. It all starts in the swirling chaos of cosmic dust and gas that orbits young stars. Picture a cosmic ballet where particles both big and small pirouette around the star in a dance that spans millions of years. But this is no ordinary dance. This is a dance of creation. As these particles twirl around the star, they occasionally collide with one another. When they do, they stick together, growing incrementally larger over time. This process, known as accretion, is the very heart of planetary formation. Now imagine a snowball rolling down a hill, gathering more snow as it goes. That's essentially what's happening here. The more mass these forming planets accumulate, the stronger their gravitational pull becomes. This increased gravity allows them to pull in more and more material, growing larger and larger over time. So how does this lead to diverse planetary compositions? Well, the key lies in the type of material that these forming planets are able to attract. Some manage to pull in more solid material, like rock and metal, forming what we call terrestrial planets, much like our very own Earth. Others, however, attract more gaseous material, like hydrogen and helium, leading to the formation of gas giants, such as Jupiter and Saturn. But what about our half-rock, half-water worlds? These celestial bodies likely emerged from environments where both solid and liquid materials were abundant. As these worlds formed, they managed to maintain a delicate balance between the two, resulting in a planet that's half solid, half liquid. It's a fascinating process that yields an incredible diversity of planetary compositions. From gas giants to rocky worlds, and now to these half-rock, half-water worlds, the universe truly is a cosmic smorgasbord of planetary possibilities. These half-rock, half-water worlds likely emerged from turbulent environments where the balance between solid and liquid materials was delicately maintained during their formation. On the rocky terrain of one hemisphere, gazing across a vast ocean that stretches into the horizon. This isn't a scene from a fantasy novel, but a reality on the newly discovered half-rock, half-water worlds. These exoplanets, with one hemisphere made entirely of rugged terrains and the other of expansive oceans, present a fascinating duality. They're a testament to the incredible diversity in the universe and challenge our understanding of planetary compositions. What's even more exciting is the potential these planets hold for life. The presence of water, a key ingredient for life as we know it, opens up intriguing possibilities. Could there be life forms that have adapted to these unique conditions? Telescopes like the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, or TESS, have played a crucial role in identifying these extraordinary worlds. These discoveries shed light on the incredible diversity of exoplanets beyond our solar system. Exploring these distant worlds poses significant challenges for future space missions. The vast distances and extreme conditions make direct exploration currently unfeasible. However, with the advent of new technology and our ever-growing understanding of the universe, the prospects for exoplanet exploration are becoming more possible. The James Webb Space Telescope, set to launch in the near future, will revolutionize our ability to study these alien worlds. Its advanced instruments are designed to peer into the atmospheres of exoplanets, unlocking secrets of their composition, weather patterns, and perhaps even signs of life. These endeavors are not just about discovery, they're about pushing the boundaries of human knowledge and technology. They're about understanding our place in the cosmos, and the potential for life beyond our own world. As we continue our journey of cosmic exploration, each new discovery unveils the awe-inspiring wonders of the universe.